Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the greatest integer function, right? So in this class we'll evaluate this important integral where we have the integral from 1 to 3 and the integrand is greatest integer of x minus 1 whole square, right? So here this problem is going to be very useful for the beginners, right? So let us start and let us first take this integral as I, right? So viewers, we can solve this integral by two methods, right? So we have already uploaded integrals of this kind in our previous videos. So we can solve this integral by two methods. The first one is the method of inequalities, right? And the second method is the method of substitution, right? So here we will prefer this method, that is method of substitution, right? We have already solved these kind of integrals by both these methods, and we have already uploaded these kind of integrals by using the method of inequalities, right? So in this class we'll prefer the method of substitution. So now let us substitute here. T is equal to x minus 1 whole square, right? So this is the important substitution here. So t is equal to x minus 1 whole square. And remember, the lower limit is 1, the upper limit is 3. So the value of x, it varies from 1 to 3, right? So when we take t is equal to x minus 1 whole square, then we can calculate the value of t when x is 1. So when x is 1, t is 1 minus 1 whole square, that is simply 0, right? And when x is 3, then t is 3 minus 1 square. So this is 2 square, that is 4, right? So when x varies from 1 to 3, then t goes from 0 to 4. So now from this relation, we can write x minus 1 is equal to square root of t, right? So x can be written as 1 plus square root of t, right? Now let us differentiate x with respect to t. So dx over dt is now equal to the derivative of 1 is 0 being a constant, and the derivative of square root of t is 1 over 2 times square root of t. So this is 1 over 2 times square root of t, right? So now dx can be written as dt divided by 2 times square root of t, right? So now we are ready to convert this integral I in terms of this new variable t. So now we can write I like this, that is t is from 0 to 4. Here we have 0, here we have 4, and we have greatest integer of x minus 1 square, that is simply t, right? And for dx we can write dt over 2 root t, right? Now see, here the limits of integration vary from 0 to 4. So here we can draw a real number line. Here we have t is equal to 0. Here we have t is equal to 4, right? And the integrand is now greatest integer of t and 1 over 2 times the square root of t, right? So viewers, whenever we come across with greatest integer function, we always search for integers, right? So here between 0 and 4, we have the integers 1, then we have 2, and then we have 3, right? So between 0 and 4, we have three integers 1, 2, and 3. So what we will do, we'll split this integral into four integrals, that is first from 0 to 1, second is from 1 to 2, then from 2 to 3, and then from 3 to 4. So now we can write this integral I as I1 plus I2 plus I3 plus I4, right? So the first integral I1 is from 0 to 1. We have greatest integer of t dt over 2 times square root of t, right? The second integral is from 1 to 2, right? From 1 to 2, and we have greatest integer of t dt 2 root t. Then the third integral is from 2 to 3. We have greatest integer of t dt, and here we have 2 root t, and I4 is from 3 to 4, greatest integer of t, then we have dt over 2 root t, right? So what we have done here, we have written this integral as a sum of four integrals. So now in the second step, what we can do, we can take this half common from all these four integrals, right? And we can write 0 to 1 greatest integer of t, and we can take this square root of t to the numerator by taking the exponent as the negative half, right? And similarly, in all these three integrals, we have the same integrand, that is greatest integer of t, t raised to minus half. Here also greatest integer of t, t raised to minus half, and here also greatest integer of t, t raised to minus half, and dt, right? So now what we will do, we'll evaluate these four integrals. So now let us take the first integral, right? Now see here, t varies from 0 to 1, right? So t lies between 0 and 1. And from the definition of greatest integer function, we know that when t it lies between 0 and 1, then the greatest integer of t should be equal to 0, right? So this is the straight definition of greatest integer function, right? Now in the second integral, see the value of t goes from 1 to 2. So t lies between 1 and 2. So when t lies between 1 and 2, then the greatest integer of t should be equal to 1. Again, by definition of greatest integer function. And in the third integral, t goes from 2 to 3, right? So the greatest integer of t should be equal to 2, right? And in the fourth integral, the value of t, it goes from 3 to 4, right? So the greatest integer of t should be equal to 3. So in these four integrals, we have written the value of greatest integer of t. So here we have 0, here we have 1, and here we have 2, and here we have 3, right? So now this expression I can now be written as, here we have half, then we have the integral from 0 to 1, greatest integer of t is 0, then t raised to minus half dt, then we have 1 to 2, here we have 1 t raised to minus half dt, and then we have 2 to 3, and here we have 2 uh, t raised to minus half dt, and the fourth one is 3 to 4, 3 times t raised to minus half dt, right? So now we have this situation, right? Now see here we have 0, so the value of this integral is 0. So we can now write half, and here we have 0, so this integral disappears. Now we have 1 to 2 t raised to minus half dt, and then we have 2 times integral 2 to 3, and we have t raised to minus half dt, and the fourth integral is 3 times 3 to 4 t raised to minus half and dt, right? So now we have a very simple integral, right? Now see, from indefinite integrals, we know that the value of this integral, that is t raised to minus 1 over 2 dt, is given by t raised to minus half plus 1 divided by minus half plus 1. So this is t raised to half divided by half, minus half plus 1 is half. So this 2 can be taken to the numerator. So we have 2t raised to half. So this is 2 times square root of t, right? So the integral of t raised to minus half dt is equal to 2 times square root of t, right? So here now this integral I can be written as half, and then we have here 2 times the integral of t raised to minus half is 2 root t, and the limits of integration are from 1 to 2. Then we have here 2. The integral of t raised to minus half is 2 root t, and limits of integration are from 2 to 3. And then we have 3, and the integral of t raised to minus half is 2 root t, and we have here the limits of integration 3 to 4, right? So now we can write this expression as half, and taking this 2 common, so we have here 2, and we have square root of t, limits of integration are from 1 to 2. Then we have 2, this 2 is left here, and root 2, and then limits of integration are from 2 to 3, and then we have here 3 and root 2 root t, and limits of integration are from 3 to 4, right? Now this 2 and this 2 get cancelled, and now we can substitute the limits here, and we'll take the difference. So we have in the first expression we have root 2 minus root 1. Then we have here 2 times square root of 3 minus square root of 2. Then we have 3 times square root of 4 minus square root of 3, right? So now we can simplify it. So we have here square root of 2 minus 1. Then we have 2 root 3 minus 2 root 2. Then here we have square root of 4 is 2. So this is 3 2s are 6, and minus 3 root 3, right? So uh, here adding and subtracting the like terms, this is root 2, this is minus 2 root 2. So we have minus root 2. Here we have 2 root 3 and minus 3 root 3. So this is minus root 3. And here we have 6 minus 1 is equal to plus 5, right? So viewers, the value of this integral I is equal to minus 2 root 2 minus root 3 plus 5, right? So this is how by the definition of greatest integer function and other concepts we can solve these kind of integrals.